Want to unravel the mysteries of black holes? No problem. All you have to do is go inside one. But it's important to know this. A person should only do this if the black hole in question is supermassive and isolated. And the person entering the black hole does not care about reporting the findings to anyone anywhere in the universe. For now, physicists must content themselves with studying black holes, the most abundant astrophysical object in our universe, from a distance. These intriguing objects have been an important component in the evolution of our universe since the Big Bang. At least in our galaxy, black holes probably played a role in the formation of the life we know to exist. The universe is like a vast zoo of different types of black holes. Black holes can be of very different sizes and have different charges, just like the charges caused by electrons or protons in atoms. Some black holes even spin around themselves. There are two types of black holes that are relevant in this video. The first is non-rotating, electrically neutral, and has the mass of our Sun. The second type is supermassive black holes, which are millions or even billions of times more massive than our Sun. Besides the difference in mass between these two types of black holes, what makes them different is the distance from their center to the event horizon. This is a measure called radial distance. The event horizon of a black hole is the point of no return. Anything that passes this point will be swallowed by the black hole and disappear from our known universe forever. At the event horizon, the gravity of a black hole is so strong that no mechanical force can overcome or resist it. Not even light, the fastest moving thing in our universe, can escape. Hence the term black hole. The radial size of the event horizon depends on the mass of the black hole involved and is key to the survival of a person falling into a black hole. For a black hole with the mass of our Sun, the radius of the event horizon would be just under 3.2 kilometers. In contrast, the supermassive black hole at the center of our Milky Way galaxy has roughly 4 million solar masses and has an event horizon equal to 11.7 million kilometers, or 17 solar radii. Therefore, someone falling into a star-sized black hole would get much closer to the center of the black hole before crossing the event horizon, unlike falling into a supermassive black hole. This means that due to the proximity of the center of the black hole, the gravitational force of the black hole on a person would be 1 trillion times the difference between your head and your toes in free fall. This kind of force is also called tidal forces. In other words, if a person falls feet first into the event horizon of a stellar mass black hole, the gravitational force on their feet will be many times greater than the gravitational force on their head. The person will experience spaghettification and will most likely stretch into a long, thin pasta-like shape and will not survive. On the other hand, a person falling into a supermassive black hole would reach the event horizon much farther from the gravity source at the center. This means that the difference in gravity between the head and the toe would be almost zero. Thus, the person would pass through the event horizon unaffected, would not turn into long, thin noodles, would survive, and would cross the black hole's horizon painlessly. In short, we don't know. However, some theorists think that black holes are actually part of a space-time tunnel called a wormhole. Wormholes can be thought of as space-time tunnels that connect different parts of the universe. Black holes are thought to exist at one end of these tunnels and white holes at the other. But unlike black holes, the existence of wormholes has not yet been fully demonstrated, even theoretically. In fact, the physicists who first proposed the idea have shown that the energy required for a wormhole to remain stably open is extremely large. Therefore, the idea remains a speculative one. Most of the black holes we observe in the universe are surrounded by disks of very hot material, mostly gas and dust, such as stars and planets that fall very close to the horizon and into the black hole. These disks are called accretion disks. They are very hot and turbulent. They are absolutely inhospitable and make traveling to a black hole extremely dangerous. To safely enter a black hole, you need to find a supermassive black hole that is completely isolated and not fed by surrounding material, gas, or even stars. Now, if one finds an isolated supermassive black hole suitable for scientific study and decides to enter it, anything observed or measured in the interior of the black hole will be limited to the event horizon of the black hole. Bearing in mind that nothing can escape the gravitational force beyond the event horizon, the fallen person cannot send any information about their findings beyond this horizon. Their journey and their findings are always lost to the rest of the universe. The mysteries of the universe are endless, so keep exploring. See you in the next video, and may the stars be with you.